All right, so get this. We're talking about AI that aced a major math exam.
And not just aced it, like really crushed it.
And get this, it wasn't even an exam it had been prepped for. Like, imagine going into a test you'd never studied for and just blowing everyone away.
Yeah, this AI basically walked into the JOKO, which for anyone who doesn't know, is China's version of the SATs, only way harder and just dominated.
I mean, it's one thing for AI to be good at stuff it's been trained on, but this is like next level problem solving.
Exactly, and that's what makes this particular deep dive so fascinating. We're looking at GRIN MoE, this cutting-edge AI model from Microsoft Research that's changing the game.
Okay, GRIN MoE. I gotta ask, what's with the name?
I know it's a mouthful, right? But it actually tells us a lot about what makes this AI so unique. GRIN stands for gradient informed.
Gradient informed.
Yeah, it's how the model learns and adapts, but we'll get into that more later.
Okay, and MoE?
That stands for mixture of experts. Think of it like this. You got all these different AI experts, each one specializing in something different. And they work together kind of like a team to tackle complex tasks.
So it's like having a whole brain trust of AIs all collaborating on a problem.
Exactly. And the gradient-informed part. That's their secret sauce for figuring out which experts to call on and how to combine their knowledge to get amazing results.
We've got this dream team of AIs all ready to go, but how do they actually work together without tripping over each other?
Well, that's where things get really interesting. One of the keys is this super clever mechanism they've developed called sparse mixer V2.
Sparse mixer V2. Okay, it's starting to sound a little intimidating.
I know it sounds super technical, but bear with me. Imagine you're studying for a huge exam. You wouldn't try to cram every single word from the textbook, would you?
No way I'd go straight for the key concepts, the important stuff.
Exactly. And that's kind of what Sparse Mixer V2 does for GRIN MoE.
It helps it focus on the most relevant information.
Yep. It's like it highlights the important parts of the textbook so the AI can learn more efficiently.
Talk about working smarter, not harder.
And that's just one piece of the puzzle. The other big innovation is how GRIN MoE handles something called parallelism.
Parallelism, isn't that like when you're writing a cover letter and have multiple tabs open to make sure you're hitting all the right keywords?
Kind of. But in this case, we're talking about the AI's ability to divide a problem into smaller tasks and work on them simultaneously without duplicating effort.
So it's like having a well-coordinated team where everyone knows their role and gets things done without stepping on each other's toes.
Precisely. And the really mind-blowing part is that GRIN MoE can do all of this while using significantly fewer resources than other leading AI models.
Yeah, I was looking at figure 1 in the paper, and the efficiency of this thing is off the charts.
Seriously, it's like getting the same amazing results, but with a fraction of the computational cost.
So it's not just smarter, it's also more efficient.
Exactly. And that has huge implications for the future of AI development.
Because right now, training these large language models takes a massive amount of computing power and energy.
Right, which is expensive and not exactly good for the environment.
So if we can achieve similar or even better performance with less, that's a game changer.
Absolutely. And to really put GRIN MoE to the test, the researchers didn't just stick to those theoretical benchmarks. They threw it a real curveball, the JADKO.
Right, we mentioned that earlier, the SATs on steroids.
And this is where GRIN MoE really blew everyone away.
So we're talking about an AI that went in completely cold, right? No past papers, no secret formulas.
Exactly. It's like they handed it the test in a sealed envelope and said, okay, impress us.
And impress it did. When I look at Table 2 from the paper, I'm seeing some serious scores on these benchmarks, MMLU, coding challenges stuff that would make even a seasoned programmer sweat.
Yeah, those benchmarks are like the AI equivalent of an obstacle course. They test everything from language comprehension to logical reasoning and problem solving, and GRIN MoE just breezes through them like it's nothing.
So not just a one-hit wonder then?
Not at all. It's like this AI is a decathlete of the digital world, excelling in all these different areas.
But back to this MMLU thing for a second. What kind of mental acrobatics are we talking about here?
Imagine the toughest trivia game you can think of, but instead of just one category, it covers everything from history and literature to math and science.
Okay, so kind of like a supercharged Jeopardy for AIs.
Exactly. It's designed to test an AI's ability to access and apply knowledge across a huge range of topics, something that's incredibly difficult, even for the most advanced models.
I can see why the researchers are so excited about this thing. But let's get back to that GOKO showdown, because that's where things get really wild.
Right. Remember how we were talking about efficiency?
Yeah, how GRIN MoE is like the Marie Kondo of AI.
Well, on the GOKO's math section, it not only outperformed other models that were way bigger and more complex, but it did it while using fewer resources.
So it's like this lean, mean problem-solving machine.
And here's the kicker. It even beat out its own predecessor, a model that was specifically designed to be more powerful.
Whoa, hold on. So it's like the student surpassing the master.
It's kind of mind-blowing, right? And while the researchers don't have a definitive answer yet, they believe this might have something to do with a process called generative distillation.
Generative distillation, that sounds like something out of a fantasy novel.
I know, right? But it's actually a pretty cool concept. Imagine, instead of just memorizing facts and figures, you learn to distill the underlying principles, the essence of the information.
So it's not just about knowing the what, it's about understanding the why.
Exactly. And that's what they think might be happening with GRIN MoE. It's not just memorizing patterns. It's developing a deeper understanding of the concepts, which allows it to adapt to new and unexpected challenges.
That makes sense, but it also raises a whole bunch of new questions, like how does GRIN MoE actually organize and access all of this knowledge?
That's where we get into this fascinating concept of routing.
Routing, like what we do with our internet browsers.
Kind of, but in this case, we're talking about how GRIN MoE directs information to the right expert within its network for any given task.
So like a digital air traffic controller, making sure everything goes to the right place.
Exactly. Think about it like this. Different parts of your brain are responsible for different functions, right?
Yeah, I don't use my language skills when I'm trying to parallel park.
Exactly. Well, routing is kind of like that for GRIN MoE.
So it can switch between different modes of thinking depending on the task at hand.
And this dynamic routing is a big part of what makes it so efficient and adaptable.
So how can we actually see this routing in action? I'm looking at figure 6 in the research paper, and I'm seeing these crazy heat maps. They look like thermal images of an AI brain or something.
That's a great way to put it. Those heat maps are like windows into how GRIN MoE's different experts are being activated for different tasks.
So the brighter the color, the more active that particular expert is.
Exactly. And what's really cool is that you can actually see how the patterns of activation change depending on the type of problem GRIN MoE is trying to solve.
So it's like watching its thought process in real time.
In a way, yes.
Yeah.
And the patterns that emerge are fascinating.
Like what? Give me an example.
Well, one of the things they noticed is that the way GRIN MoE handles STEM-related tasks is completely different from how it processes humanities stuff.
So it's like it has separate AI departments for math and literature.
Exactly. And that kind of specialization is what allows it to be so effective across such a wide range of tasks.
So it's almost like GRIN MoE has developed these specialized skills.
Right, like different parts of its AI brain light up depending on whether it's tackling a geometry problem or analyzing a poem.
It's pretty mind-blowing when you think about it, but is there a way to actually see this specialization in action, like at a more granular level?
Absolutely. Figure 7 in the paper gives us a really cool example. They take this math problem from the GAOKO,
Okay.
and they break down how GRIN MoE routes information at different stages of the problem-solving process.
So we're not just looking at the big picture anymore. We're zooming in on the individual steps.
Exactly. It's like watching a master chef at work. You can see how they use different skills and techniques at different points in the recipe.
Okay, I'm looking at the figure now, and it's like each layer of the model represents a different stage in GRIN MoE's thought process.
Right. And the really interesting thing is how the routing strategy evolves over time. So in the early layers, it's like GRIN MoE is casting a wide net, activating a bunch of different experts to gather as much information as possible.
So kind of like doing background research before you start writing a paper.
Exactly. But then as we move to the middle layers, things start to shift.
Getting more focused.
Right. It's like GRIN MoE has identified the key concepts, and now it's calling in the specialists, the experts in those particular areas.
And then in the final layer,
That's where it all comes together. All those different strands of information and expertise converge.
and boom, out pops the answer.
And what's remarkable is that this whole process, this dynamic routing of information, it all happens automatically.
So we've created this AI that can not only solve these incredibly complex problems, but it can also figure out the best way to do it without any explicit instructions.
It's a whole new level of sophistication. And it really makes you wonder, what are the limits of this technology?
Right. If we can create AI that can adapt and learn like this, who knows what the future holds?
And I think that's what makes this research so exciting. It's not just about building smarter machines. It's about expanding our own understanding of what intelligence is and what it can be.
Well said. It's been an incredible deep dive. We've gone from the nuts and bolts of how this AI works to pondering some pretty big questions about the nature of intelligence itself.
And that's what we're all about here, right?
Yeah,
Exploring the cutting edge of AI and what it means for the future.
absolutely. So, to our listeners, thanks for joining us on this mind bending journey. Until next time.